This video is going to show you how to define the room spaces and all associated information around the definition of the rooms. And starting a project, of course. So here we are on the projects interface. We're going to start a new project, selecting the new button. This then describes the process that we're going to undertake. So we're going to set up the floor plans we're going to work with, define the geometry, building elements and profiles, and work on our services. There is a distinct workflow path you need to take, so you will decide which of these workflows that you're going to do. Either you're going to bring in GBXML from a Revit or 3D software package with a view to using the inbuilt SIBSI admittance method calculations. Another workflow is to bring in the building geometry from Revit or any other 3D package and then import the resulting TAS simulated results. The third option will be if you have no 3D model and you have built and constructed the TAS model, you're able to bring in the entire TAS model and the results. And the last option here, use the 2D DXFs to create a building model by tracing around the room boundaries and then utilising the SIBSI admittance method in order to perform the calculations. The method I'm going to show you in this instance is this last option here. If in doubt, you have the information tooltip. Every project that you set up will have a title associated with it called Untitled Project, and they'll be numerically sequential. Obviously we can change these. So call it Setting Up. Next, you select your database, your weather database. So you can select any location you wish and use the data from that location. There is a separate video on customizing weather databases, information of that such. You do need to customize the database prior to setting up a project normally, but if you have selected a location and you do subsequently need to change it, then all you do is complete the setting of the project, save it, exit it, and then follow the weather database video that is in a separate location. We then start thinking about the number of floors on our project. So this one is a 4-story building, setting up the heights. So we've got our various floor to ceiling heights. So let's say we've got from our floor to our ceiling grid is 3 meters. We have a ceiling void depth of 0.8 meters and a thickness of our slab between the floors of 0.2 meters. That will total 4 meters. So the elevation of the first floor will be 4 meters. Elevations can be different up through the building. And of course, once you've defined the rooms, you can change these ceiling grid levels as well. We then select our floor plans. Go and identify the floor plans we're looking at. And we'll select the ground floor DXF file. We use the DXFs. You take DWG files and convert to DXF. If you have multiple floors on the same drawing, you take copies of those drawings, you then extract the floor plans that you don't want and move them all so that they are then relative to the origin. So you have a series of floors on each level, each in the same place, so that when you level up and level down in the software, you then get the floors in the right place. These have been derived from Revit, so they will sit one above the other because obviously in a 3D model that's the case. Next, in the first floor, and again revisiting the directory containing our DXFs, selecting our plan. Next again, picking the floor plan up. Next again, roof. Again, picking the floor plan up. Proceeding onwards, we then have the orientation. This is important for your heat gain calculations for getting the pathing of the sun. If you're only doing something like public health or heat loss calculations, this isn't as important. It's not critical, but certainly for cooling calculations it is. That is with respect to true north. So that implies north is always up the screen and off to the right 45 degrees. So the top of that building model represented north-west face. This is the DXF location check. This shows you whether your floor plans are lined up or not. Again, with reference to earlier, this is from Revit, so they will all line up. If they were all over the place and misaligned, that would be the point at which you come to the conclusion that your floor plans don't line up. And you would then find that later on when you come into the building program that they're all over the place. So at this point, you can make the decision to tidy up your drawings and reintroduce them. This then takes us into the building program, where we get first of all introduced to our structural elements, our standard elements that we can use. We can create our own. There is a separate video for calculating U values of structures and how to incorporate that data. Separate video for that. You then select your preferred default material. So the implication being, whenever I select an outside exposed wall, it will be using this L1A 2013 wall. If I select glazing, it'll be using whatever glazing I select from this listing. Internal elements uses the same principle. We then move on to profiles. We can create our profiles by editing the first one, giving it a reference where we can put our set point temperature for cooling, for heating, along with our set point arbitrary temperature for summertime calculations and our relative humidity. Ventilation plays an important part of the calculation, so we have our natural infiltration. This can be calculated on a room by room basis. Obviously the same profile 20 stories up will display different infiltration rates, hence the greying out of the button. That's done on a room by room basis. Mechanical ventilation can be handled two ways: ventilation in litres a second per person, or a set volume flow rate, and again on a room by room basis, air changes an hour can be specified. So I'll assume in this case 10 litres a second per person. Occupancy tab, so many square metres per person, with various on and off times, and the activity level implying the metabolic gains for sensible and latent. Lighting can be put in, so we could say, okay, 8 watts per metre squared, so we've got LEDs or something. Later on, if the lighting people get involved in the design and you come back to the building and energy program, it will flag that and it will ask you whether you wish to update. And this second column will then be populated by the actual gains from the manufacturer selected fittings, and this initial column will be reset to 0. That's a choice you make. The program will prompt you for that choice. You decide what you want to do. As far as efficiency of lighting is concerned, we have the control methods for Lenny and Part L calcs. So we could say our offices are daylit, and I can apply my lighting controls. The more elaborate controls you have, the more chance you have of passing the Lenny calc. And then we have equipment gains. Selecting OK allows me to move on to the next profile. I can actually import profiles from another project as well if I wish to. All I need to do is select import. We have two choices from here. We can either import from a previous project, or we can import from a database of constructions that we have, profiles that we have based on NCM. So I'll go and select one of the standard default profiles that we've set up that you get with the software. So here we are in the default profiles folder. It's held in the MEP Works 2021 or the MEP Works version that you have. Files, examples, profiles. This is the directory of our prescribed building types. If I select the office type building, I can then import these profiles, start using them. They can still be edited. Once we've completed them, we can then go in and edit them and make any changes that we see fit. You can see here we can actually customize these profiles. We then nominate our preferred profile. So if I select office and set that as the default, looking at the plan, you can see there are more office rooms than there are other spaces, so that makes sense to have that as the default. So here we are in our floor plan. A little bit of a chat about moving around the layout. If I push my control key and roll my mouse wheel forward and back, that levels me up and down through the building. down to the ground floor. If I put my mouse my mouse cursor in a room space and I roll my mouse wheel forward, the program will try to zoom me into that part of the building layout. Then what you can do is push your mouse wheel, pan, let go. So these are the same sort of commands that you get with most CAD systems. Rolling back moves you out to the home view, zooming you in, rolling forward. You can actually produce marquee boxes as well. If you want to zoom in on a group of spaces, you don't have to use the mouse. What you can do is use the view ribbons, and to zoom in, I can put a box around, say, these 3 rooms, click once, let go of my mouse button and drag out the window, and then click for a second time, and that zooms me in as well. I also have previous zoom to take me back to the previous view. So now in a position to start defining the rooms. I'll start off by a fairly simple room. There are 2 stages to this: defining the shape of the room, then selecting the faces. So first of all, making sure we are on the Insert menu, we select Room Definition. Typing in our room name, selecting the profile. Notice Office is the default. If this one was different, we could select a different profile. Next. Next again, and we then click around the boundary of the room. If I envisage I might need to change the shape of my room, I can always make changes by breaking faces. So I can split the face into 2, single click, click on the start point of the room, and then you know the room is bounded because you have this floor and roof balloon appear in the middle of the room, and the program is now inviting you to click near the middle of the wall or inside the floor ceiling selector. So I want to put these windows in. So first of all, I click once to select the wall. There's the material type. You need to keep an eye on the exposure. If it's an internal wall, then you will get your preferred internal wall. It's not internal, it's external. Having ascertained that face, we can see here we've got 2 buttons here. Next face, next element. Next element is for the inclusion of any other element within the wall. In this case, namely a window. So by selecting next element, all I do in plan form is click across the width of the window, putting the height of the window in, putting the start height, which is a generic term in this case because it's a wall or sill height. So I'll put that at 0.7. We then move on to the next window, next element again, and we select the next window. Notice how it maintains the previous dimensions, which you can change if you need to. That concludes the face. Now, the only other face I really need to select in this case is the ground floor. We're looking at the ground floor layout. So if I select next face now to move on to the next face, and now I select floor, and it's exposed. I don't have to necessarily select every face on the room space. The reason being, the program will know if you don't select a face that it's an internal face. It could be internal partition, internal ceiling, or internal floor, and it will use the prescribed material that we selected earlier on from the structural elements database. If I do want to select a face, it's merely a case of selecting it and saying next face, selecting the face. I might want to deviate from that. That's actually internal, so it would be internal. And I would then decide that this is actually not using the default material, but it's actually some sort of stub partition. So if the material deviates from the standard one that we've selected, then yes, we would have to select the internal face and pick the different material. While I'm doing this, I might as well continue. So I'll select next face and do that one there. And let's say that also is a stud partition. It's internal. It will always use the default from the last material. So keep an eye on that when defining your rooms. If you went to an outside wall, it would still be ticked internal. You need to change it. I'll change that back into a stud partitioning as well. And I might have a door in there. So again, next element, click across the width of the door, specifying the fact that it's a door, specifying whatever door type that you want. Next face again, internal, and again we'll select that stud partition. and then I'm going to finish this room. Prior to finishing the room, you have several options. I can put a ceiling grid in. By putting the ceiling grid in, I can specify my panel sizes. I can decide how I want to place it manually, wherever I click in the space, it will radiate the panels out from that position. I can have tile center at room center, or I can have intersection at room center. That then presents you with your ceiling grid. I can go in and edit the profile on the space, revisit any of these tabs, make any changes I wish. I can also visit the face data. You'll notice from the video here you can see the colour convention. Pink implies plaster, which implies an inside face. Red, brickwork outside, blue, glass. If you look at the layout and you find you've got red internally, then that means you've got a external wall internally, which will be obviously incorrect. So we can go into the face information here and we can change the categories. So for example, if I go into the wall or a partition here, I can come in and change any of the materials associated with that partition. And you can see on the backdrop here, you get a nice thick red line to show you which face you're looking at. And on the header here where it says partition, this is where you get the ability to change the exposure. So you have wall in sun and wall in shade, i.e. a wall that's totally in shade, perhaps north facing against an alleyway or something of that nature. Diffuse radiation only. Ambient response to a swing in the outside condition in the absence of any solar impact. So let's say an underground car park or a building on stilts with a car park underneath it or an exposed floor. Temperature difference implies it's an internal partition. It responds to temperature differences across the internal face because the program automatically allocates that based on the temperature of the space next door. So you can change the exposures and of course you can change the materials. If we look at the external wall, we can see the various windows. So if I'm stood in the room looking out, that represents these windows. Each of these windows can be changed dimensionally by changing these values on the field entries on the right hand side here. Once I've completed the room, I can still edit that data. The program is going to want me to select the next space. I want to break that chain of command, so I cancel that because I don't want to add another room at this juncture. If I want to revisit the room, for example, I called it Office 1, but it's only got a room number in here. This is where you can go to Display Options, and this is where you can decide what you want to see on the screen. So on the drawing, I called it Room 1, so I don't need room numbers, but I'm going to show room names. There's all your colour conventions, and I want to show text at fixed size. So no matter how far I zoom in and out on a layout, you can see that text assumes a fixed size. If I want to revisit the room and make any changes, I click once on the room. I've got several choices available to me. I can go to the Edit menu and select Profile, Ceiling Tiles or Face Data, or I can do a right button click and select Profile, right button click Ceiling Tiles, right button click Face Data. The right button click option always gives me the ability to copy a space. Select the room, right button click, copy room. That puts a ghost image of the room on my mouse. Position the room next door, click once to place it. I get another one floating around, press escape, and I can then squeeze the room. Notice these grips, you can squeeze the wall spaces in. So you can use these grips to make the change. If you envisage you might need to change the actual shape of the room, having broken these walls into two, it might be decided that it's maybe a hotel room where you've now got to include the bathroom separately. So you could actually do that and then define another room separately. So you might want to be mindful of that when defining the room spaces in terms of possibly changing the shape of the room. I can also copy this room across the other side of the corridor as well. So I can do the same thing, select the room, right button click, copy room. I can then drop the room down in position, but it's going to be a perfectly handed version of that room. Notice how the window is on the inside. So all I then need to do is click in the room, right button click again, and then I can click the room vertically. That swaps the room around, and notice the door in the same place and the windows are in the same place. So you could swap rooms across a corridor as well, and then perhaps I could roll this one out along its length. Probably would do this one actually, because this one is a different width, so I'd take this one and do the same. Copy room, drop that down, press escape, right button click, flip room vertically. I could take a copy of this room as well, right button click, copy room, drop the room into position, press escape, right button click, flip room horizontally. That then puts the door position in the correct place. I can then tidy up the room by grabbing the grips. That's then sorted the room out. If we define a slightly more complicated room, the only real difference between this and the single room is the moving on to the next phase. So again, if I insert the room definition for the conference room, that's now a meeting room, so I'm changing the profile. Again, clicking around the room boundaries. Notice the X is switched on and the O is switched on. The O is the orthogonal, the X is the XF snap. Depending on the complexity of the XF, the snap will snap to the nearest line. So if it's fairly complicated floor plan with lots of hatching and zoning in the wall areas, it may snap the end of a line that you don't want it to. So only you can determine whether you think that's a viable setting to have or not. So again, we're selecting the wall, clicking halfway along the wall, then selecting next element. I'm just going to take this off as one large window because I'm lazy. There's the window there. Notice the same dimensions, those could be changed. So we need to move to the next face now. So we select next face, halfway along the wall to select it. Next element, again we have the window. And then I can complete that process. I can select next face, floor, and I can finish. I could go through the process of again putting the ceiling grid arrangement into the room space. And I could roll that room out, right button click, copy room, just pan down. So you do have the facility to pan even though you have the floating room on the end of your mouse. Click it into position, press escape, right button click, flip room vertically, zoom in, tidy up. Unfortunately, on the tidying up process, there are no snaps to the BXF file. It's only when defining the room itself. There we have our rooms defined. And just to complete the process, I would grab that room there, copy room, drop it into position, right button click, flip room vertically. And that sets me up nicely to show the next video on copying between floors.